Okay.
You're going to learn about pressure and volume today, whether you like it or not. Okay, so this is the video interview project. She's not a science major. I am. Let's learn stuff.
Let's do it.
Okay. So let's see. What do you already know about pressure and volume?
Oh my god, stuff that I haven't remembered since high school junior year.
Okay, so what about it? What do you, on like the most basic level, talk to me about pressure and volume.
Volume is not like the space something takes up.
Mm-hmm.
And then pressure, it's like... I, for some reason, know more about volume than I do pressure. That's not good.
So is pressure the same as volume in a way that like it's just kind of in a contained space?
I think so, yeah. Isn't
Or-
pressure more gaseous and volume is more liquid and solid?
Well, volume can be either of those, because if you have gas in a container, isn't that the volume?
Okay, yes.
So-
I'm a writing student, y'all. I don't know much.
So an easier way to think of it is to think of pressure as a driving force. Volume is your consistent thing, and then pressure is what's acting on what's already there.
Okay.
Okay, so let's think about the human lungs.
I'm just doing faces to your video, by the way.
Let's see. Okay, so here's a handy dandy bag that we're gonna put some air in.
Okay, let's learn about air.
And yeah, I think this has a hole in it.
Most likely has a hole in it.
Oops.
It's from ShopRite.
Okay. Yeah, so this is what we're working with today. Okay. So basically, if this didn't have a hole and you filled it up all the way and put enough pressure on it, it's gonna pop, right?
Okay, yes.
So you kind of need somewhat of a similar system for the human lungs. But you also can't have it where this doesn't allow any exchange, because in the human lungs you need gas exchange.
Okay.
So what are the two gases that are at play in the human lungs?
Oxygen and carbon dioxide?
Yes.
Oh,
Hey.
that's from junior year high school. I'm a senior now. What up? Not in high school, I'm a senior. That's a year of education. Oh, God. It's really bad. God, you can really tell that my face is round and you have more of an oval.
Let's relate that to science.
What kind of pressure goes into a round face
my
and
God.
volume goes into an oval? Ovaltine, Ovaltine.
So if you know what volume is already,
Mm-hmm.
and then pressure is just some kind of force acting on it, do you think that these things have some sort of relationship going on?
Yeah.
Are they seeing each other?
Oh, I was about to say, I'm
Long
like, wait,
distance?
I really was not getting the joke at first. I was like, what? This is the best video for you guys to watch to learn stuff. I mean, definitely there's a relation. That's what I thought before today.
So if there is some sort of relationship between pressure and volume, do you think it would be constant, like no matter what one, like if you just push in on a volume, is it always going to react the same way?
I feel like yes, but at the same time, if it's a different substance in there, then it could react differently. Like, say it was goo.
Yeah.
If you keep
Let's
pushing on
YouTube slime. Let's get
yeah.
into-
No, I'm just saying, like, if you keep pushing on something like that, it's not
Yeah.
gonna like pop. It's just gonna flatten, squeeze, and so like,
Yeah.
like the stress balls.
Mhm.
So
Yeah, so that's kind of like a real life example of it, and
Okay.
like relating that to something as vague as pressure and volume is a lot easier of a way to look at it than just thinking, oh, pressure, volume.
yeah.
So depending on what the substance is and what the environment is, you have a different relationship going on with it. So if you're talking about the human lungs and it's going in or out with air,
Mm-hmm.
if you had to define that relationship, what would you say it's like? Direct, indirect, inverse?
Direct. I don't know, I was just kind of guessing.
Oh no, it's fine.
I was just kind of guessing. Because I kind of zoned out there.
And that's why we have different majors. Okay.
I write
so-
pretty things. I don't do
So
science.
let's think about this.
God, I'm coming off as a moron.
No,
No.
I still find it difficult myself. Like,
Oh my god, I'm
and
just
it's
tired, guys.
It's more difficult
I
to
took a nap.
explain it. Okay. So the human lungs are kind of like a closed-off system,
Mm-hmm.
and you want pressure and volume to work in a way that makes one, like you have to have it come in and go out. So you need the force, like you need some kind of volume to fill it up, and then something to push it out, and then pull it back in again.
Okay.
So there is a relationship at work there, but it's not really what you would think it would be. It's more of an inverse relationship. So let's see.
What's next on the agenda?
Oh my god.
I'm so excited to learn about science, guys. I'm so pumped.
Jesus Christ. Okay. So basically, whenever you have an increase in volume, the pressure goes down, which you wouldn't expect, because if it's being expanded, wouldn't you think that there's more pressure on it?
Yeah.
And then if you have
Well, no, I would think there's more volume in it.
Yes.
Oh shit!
Yeah.
Oh shit! Oh no! Oh, I'm not supposed to say that.
We don't say that kind of stuff here.
Sorry.
Yeah.
Yeah, all grown adults.
Okay. So that's part of it, because it's kind of easy to confuse pressure and volume,
Yeah.
because one's the force and the other is just there.
Okay. Yeah.
So, and then the other part of that inverse relationship is if you have less volume, you're going to have more pressure.
Mm-hmm.
Does that make sense?
Yes.
How so?
Fuck, I was really listening.
Okay. Opposite of
Sorry.
you
Oh god.
you have less volume, therefore more pressure.
Yes. I have less volume there.
Okay. So in regards to the human lungs, you only have like a certain capacity that you can breathe in.
Uh-huh. No, I'm sorry, that was totally not scheduled.
You only have a certain volume that the air can take up. So once you reach that volume, you have to think about what's going on in the atmosphere too, because if you think about it, like when people go in submarines, there's a lot of pressure going down on them, and when you're just like in the regular airspace, there's also the pressure from the atmosphere, or ATM.
I know that's also why, like, they say divers, if they go too far down, they'll pass out because of the pressure. Example, kids, people die.
So if you went down and you had a bunch of oxygen,
Yes.
is that do you think that like that's a good gas to have, or do they use a different gas for other reasons when you have some sort of scuba diver?
Don't they mix something in there? Yeah.
Nitrogen can handle more pressure.
Okay.
So let's go back to the surface.
Okay.
So with atmospheric pressure. So basically, it's always changing between which system has more pressure. The air just in general, or the air in your lungs.
Okay.
So, did you ever learn about diffusion in bio? And if so, do you remember what it was?
I actually never took bio. I took physics
Okay.
instead. Yeah, and chem.
Okay.
Oh no, wait! I did take bio. I took
Like,
bio.
really?
Well, no, I took bio in 7th grade.
Okay, okay.
Yeah, my middle school taught it. I didn't go in high school, so it's been almost like 10 years. Actually, I was good at bio. They'll ask me the questions.
Okay, okay.
That's good.
So, when you have simple diffusion, let's say that you have a lot of water in one area and not a lot of water in another area.
Okay.
Which way is the water going to flow?
The water does
Low
not
to high or
the-
high to low?
High to low. Yeah.
So, one of the concepts in systems physiology is that it's always going from high to low, and it follows that simple diffusion model. So, basically, when there's more air in the atmosphere, which like you would think it's always like that, but it's not. When there's more air in the atmosphere, it wants to flow into your lungs.
Okay.
But then if you're comparing like all of the space in your lungs is taken up by air, and you're comparing that to the atmosphere, which might not have air like everywhere, I guess, you technically have more air. So it's going to go out. It's going from the high concentration to the low concentration outside. Does that make any sense?
Yeah, that does. Yeah. Like
So-
I said, I'm good at bio. I'm okay at high school bio.
So if you had to explain it using the words volume and pressure, how would you say that it works? Like going from high to low?
Like, wait, just like, explain why that would happen.
Yes.
That's what you want, using the terms
Yes.
pressure and volume, right?
Yeah.
Is that what you said? Okay. Well, the pressure, wouldn't it be like kind of like air pressure pushing it down, falling into?
Yeah. So is pressure just some kind of inanimate thing?
No, I think it needs to
Or-
be pushed by gravity, right? Yeah.
Well, it's just a force. At
Okay.
work.
It needs to be pushed as by any kind of force,
Yeah.
rather it be like liquid or.
Like the actual container. Like it might be working on the container.
Yeah. Okay. And then the volume, it would be the increasing of volume in the one that has less water. It's like that. So.
Yeah.
Layman's
So even though it's kind of confusing, when you're breathing in, your lung capacity expands, and you would think that there's more volume in there, but there has to be a little bit less so that it can get out.
Okay.
Yeah. So does it make more sense when you're talking about inverse relationships between pressure and volume?
Yeah.
Okay. Let's see. So could you put it together on a whiteboard or a blackboard in this case?
Okay. Yeah.
Show us your artwork.
How come you want to?
I'll probably have to after.
Okay. Wait. Shit, I'm a shitty artist.
Don't be shy, I know you're an amazing artist. It's okay if you're not a science major. What? She knows ahead of time that this is for educational purposes only and that it's not going to be a viral video on YouTube, unfortunately.
Oh my fucking.
I promise. I told her ahead of time it's not going to be like that. Keep going.
I swear to God. By the way, kids, I'm a 3.5.
She's smart in her own ways. In not science related ways, okay? Just like I might not be good with artwork.
You can edit that out.
Oh my god.
I'm actually quite good at science, guys. Just saying. I'm not good at math, though. I'll proudly admit to that.
We're halfway through.
Whew, better take a break. It's thirsty business, guys. Get it? Because it's water.
Stop.
Okay, so,
Okay.
pressure brings it down. Oh, there you fucking go.
Okay. Alright. Hello, you can still see me, right? Okay, so in this instance, what's going on with pressure is you're either going to go up or down.
Going down. Pressure is going down into the lower one, right?
Yes.
Yeah.
So then what's volume doing?
Going up.
And then in this case,
Pressure is going up. Volume is going down.
so sometimes it's kind of more difficult to think about it in terms of the human lungs because it's not as straightforward as this. It's kind of like a bunch of little amalgam things. And
So a flower.
well, kind of. I mean, there has to be something that comes down. Yeah, more flour now.
Yeah, it's a flower. Your lungs look like a flower, kids.
Step away from the drugs.
Yeah, right.
Okay, so if we're comparing these two, and there's all this area on the surface here, and then there's not as much here, like it's just what's given. Like there aren't any like loops here, or like doesn't come out more here. Which one, if this were the case of the human lungs, which one could have more gas exchange? Why is that?
Because there's more space available in there, right? For gas or for a gaseous liquid or gaseous object. I'm fucking tired.
Actually, no, because this one is more straightforward. Like, it looks like there would be more, but if this were the same size as that one, this one has all these different loops that can take on more surface area, as opposed to this one would probably look more like that. This is just very defined, whereas these have more surface area. So when you're in your lungs, or just in the general, the general human body, you really want surface area. And then you also need diffusion. So these are two like really basic concepts, but they're present in like larger systems like the human lungs. What time are we at?
19.
Okay. So let's do a model of the lungs to basically sum it up.
I swear to God, if this goes on YouTube.
Like seriously, like, can I just say how beautiful my lungs are?
Yeah, go as slow as possible. Makes it like every time.
Like special ed. let's see. If we've just exhaled, what is the pressure going to be like in your lungs to get the air out?
Oh, so it would be more up. Volume would be down.
And then
You inhaled, pressure would be down, volume would be up.
okay. So then So then back to that idea of surface area. Are your lungs just kind of flat and like that's it? Kind of like that bottle or like the glass that you were drawing before, it's just flat and that's it? Or do you want little branches?
Little branches?
Mm-hmm. And they all have that little grape thing coming off, that's the alveoli. Which increases the surface area.
Mm-hmm.
So if you have thousands or millions of these microscopic little circle things, you get a lot more area than if you had thousands of microscopic little squares. And why is that? If you're thinking about like a 2D square as opposed to a 3D ball, one of them has a lot more dimensions to it because it's 3D, as opposed to this one just being flat and like that's just kind of it. So like you could have exchange happening, let's say. So you could have exchange happening here, on the back, up here. Boy, look at me. Wow. But it's kind of difficult to draw that out because I'm not that great at drawing. So could you draw a more 3D version of an alveoli? It's kind of like a grape. Go on. Oh, did you just notice? Is that what it looks like? Yeah. It all. Okay. Oh god, that looks even worse. Is it like that? See if we can actually. Please don't. Or add like another loop here, and then another loop again. So 3 times. Yeah. So slide over a little bit so they can see the audience. Wow, that looks like a cartoon foot.
I like from like the Flintstones.
Yeah.
Yeah. There's like cartoon bird foot, like a Dyson.
So instead of it just being like flat like this, it has that outer. So that's like the back of it. Not sure if it's doing it justice. Here's a little shiny part. And because of the dimensions, there's more surface area. So you would want that to be in your lungs.
On both sides? In both?
Yeah. So why is there like a weird little gappy thing here? like a little notch in your lungs.
I don't know, is that like the muscle where it's like extends out? No. No.
What's here in your body?
In your chest or heart? Yeah, sorry.
Yeah. So your heart kind of fits right in there.
Technically, that is a muscle that goes.
What?
Technically, it is a muscle that goes.
Yeah. So when you're also thinking about what's doing the exchanging, so you have these that are all exchanging, but what system throughout your body is the actual exchange system? Like what reaches basically everywhere in your body? Blood. Yeah, so the blood is going through all of these and it's performing that surface level exchange, and then it has to go to this really important organ to get it out to the body. And I'm trying to remember. I don't know if we have to go in depth about it, but I know when it goes out the left part. Oh, wait. So if you're looking at the human body, which part is the left side and which is the right?
If I'm looking at it or if I'm standing right here?
If you're looking at this, which one is left and right?
No, so this is left.
We're facing.
So that's left. No, this is my left hand. I'm looking at it right there. Oh, facing the person. Okay, so then this is left.
Yes.
Okay, yeah. That's what I said before. You made me look like I'm an idiot.
I didn't know if you were just guessing the first
No,
answer.
I wasn't guessing. I thought literally. Well, no, I thought we were talking about us.
Oh,
On our body, but then looking at the person. Okay, yeah.
Yeah, so it's a little more confusing because you would think that this is the right side, even though it's not. And when it's in the left circuit, this one is going out. It's not really going to the lungs. It's usually going towards this big vessel or up into the thick vessels in your neck. So, do you remember what the name of this one was? Like the big one that, like, if you get it cut, you're dead. It starts with an A.
Artery, but
It's a type of artery.
I know. I'm trying to think. Honestly, I forget.
The aorta.
Aorta. Okay.
Yeah. So it's that big chunky one going down there. And that is where you want the left side that has all of the new oxygenated blood from the lungs. You want that to go into that aorta or up to the brain because the brain needs blood all the time. So then going a little bit deeper, branching off from the lungs, air, pressure, and all of that to blood, and then thinking about how important the brain is. Would you just want any blood to get up in here?
No.
So what kind of system do you want in place? Because it does need blood, but you also want to think about how you need to make it selective for blood. So if you're ever having a snowball fight and you want to get out and you want to protect yourself, but you also want to let people in, you want some kind of barrier.
Okay.
So that acts as a specific way to filter out what you wouldn't want to get to your brain, because no matter what, your brain is always getting blood, and you want to have it so that certain diseases and bad stuff doesn't get there. So if I gave you this bag again, and it didn't have a hole, and you had to explain to me about pressure and volume, how would you go about it?
So this is pressure,
Okay.
and volume is the air that fills it up. So basically,
And then how do those systems work off of each other?
they're opposite. So like, say pressure's up, volume will be down. If volume is up, pressure will be down.
Okay. And then one last question in relation to the human lungs, which is a lot more complicated than just a paper or some kind of bag. So if you get a puncture in your lung, what is happening there, and why are you losing?
Well, you're unable to do that system of opposite, essentially, pressure and volume. So without that, you're not really able to get the oxygen that you need to live, or the blood going through.
True. So what system has a higher pressure at that point? I would think your lungs have a higher pressure and it's leaking out.
Yeah, that's what I've been,
Oh, okay, yeah.
Yeah, I was kind of
You gave me a weird look.
Well, no, because I already said it, so I was like, wait, I thought there was a guy I got it wrong, so. Okay.
No, so like a lot of the time with systems physiology, you have to think about diagnosing stuff. So you have like a really good system at play, but your issue is that it's not always going to be the case. And like sometimes you might have damage to your lungs, or like you might have like some kind of puncture, and that really disrupts those systems. So when the body wants to maintain that sense of regularity within itself, do you know what the word is for that? Homeostasis.
Okay.
So if you're thinking about homeostasis in a general sense, do you want it to just be one value where the body is just always at that point? Or would you rather you have a set of points?
Probably a set, because your body has to adjust to certain things,
So basically, would my set be the same as yours?
No, it'd be different based on different body chemistry.
Yeah. So can you think of like a real life example of that, where my homeostasis is different than yours?
Maybe if we lived in different environments.
Okay, but let's say
if we're sick, have a certain disease.
Let's say that we're in the same cold room.
Okay.
Are we both going to react the same way?
No, it depends on like blood pressure.
Yeah, so depending on like different parts of your body and how they work together, you'll have different homeostasis. Stases.
Yeah.
And then picking up on the different senses throughout, or just picking up on different stimulus in your environment. Am I going to pick up on pain the same way that you would? So what's that difference?
Different nerve endings of some sort.
Well, no, you have to have all the same ones.
Well, I mean, like, then would it be different, like, functions of pain, like how you feel it? Like sensory issues?
In how you feel it, I might not have any issues with feeling pain, and you might not either, but we also pick up on it different ways. So in a sense, we perceive pain differently. So if you had to sum up that general way of picking up on stimulus and responding to it differently, what kind of a word would you say?
I don't know.
Perception.
Perception, okay.
Yeah. So basically it's different for everyone, but you do need some kind of normal. And that's basically what systems physiology is.
Yay!
So do you have any questions?
No.
Okay. That's it for now.
Bye-bye.
Yeah. Bye.
Bye.
Boop.